Alright guys, welcome to Crown Smart. In this video we want to solve something special. That's why it's called special limits. Okay, it's a continuation of the limits. Okay, so we want to solve the special limit. Now if you check out all my other videos in calculus, you're going to find out that I differentiate cos x and sin x using what? The definition or the first principle. So I arrive at a part where I have the limit of this. Okay, and I said that the limit of this is equal to 1. I say there is a proof. Actually, there's a proof. And the limit of this is equal to 0. So that's what we want to show here. Okay, so there are various ways to show this, but in this video, I just want to show you a very simple trick to solve this. And it's just fun. Okay, so now, you know I love this because it's special limits. So now we want to find the limit of this function. Okay, now the limit of this, we want to show that the limit of sine h all over h is equal to what? 1 as h approaches what? 0. Normally we're going to do this limit by substitution. Okay, so we have f of x. Okay, f of h, sorry, no, let's not do f of h, let us do the limit as sine h over h approaches what? 0. Now if I include this value, I'm going to have sine 0 is what? 0 over what? H is what? 0. So this is an indeterminate what? Case. Now what do we do? Now we're going to invite Taylor series in this problem. So in Taylor series expansion, the way we expand sine x, okay, in Taylor series, okay, sine h in Taylor series, this is defined as h what? H minus x cube all over, no, h cube all over 3 factorial plus h 5 all over 5 factorial minus h 7 all over 7 factorial plus h 7 9 all over 9 factorial minus ... and so on and so forth. See, the Taylor series is an infinite sum, okay, of this. So now this is a way of expressing sine h in this form using Taylor series. So we're going to use Taylor series to do what? To simplify this function. Okay, so now we know that observe that the power of h are odd. Okay, 3, 5, 7, and the corresponding denominator has odd factorial, 3 factorial, 5 factorial, 7 factorial, blah blah, and so on. So we now do this. Sine h over h is simply, I can say this is 1 over h times sine h, which is something as 1 over h times h minus h3 over 3 factorial plus h 5 over 7 factorial plus h9, oh sorry, this is 5, so this would be minus, this would be 7 over 7 factorial, this would be 5 factorial, sorry, my bad. Okay, this would be plus h 9 over 9 factorial minus ... Okay, that continues. So if we open up this bracket, we have that h cancel h here. We have this as 1 minus h squared over 3 factorial plus h 4 over 5 factorial minus h 6 over 7 factorial plus h 8 over 9 factorial minus ... Okay, now this is beautiful. Now we're going to apply the limit of this. Okay, so just in case, just do limit as h tends to 0. So it's simply the same thing as saying limit as h tends to 0. Okay, so I just adjusted it. Okay, so when you do the limit as h approaches tends to 0, just simply put the h there. Anyway you see h, put 0, so you have this as equal to 1, because 0 squared is 0, 0 divided by this is 0, plus this raised to the power of 4 is 0, divided by this is 0, and so on and forth. You keep having zeros, infinite zeros. So let's put the 0, this is equal to 1. So you see how we have shown that this is equal to what? 1. Okay, now let's show the second one. the limit as h approaches 0 cos h minus 1 over h. Let's show that this is equal to 0. Now, before we start, cos h minus 1 over h is the same thing as, we can say, this is the same thing as saying cos h minus 1 over h. Okay, now I will just multiply it by the conjugate, that's change of sign, cos h plus 1 all over what? Cos h plus 1. Okay, now the reason I'm doing this is because this cancel this does not change anything. It does not change anything at all. So it's like saying 1 times this. Okay, now remember your difference of 2 square, a plus b, a minus b. This is a square minus b square. So we apply the same rule here. We have cos square h minus 1 square, okay, all over this is equal to all over h times cos h plus 1. Please, this is not cos, this is cos h. Okay, now observe that cos square h minus 1 looks somehow familiar. Now let's draw your mind back. Recall that sine square x, okay, let's use h, plus cos square h is equal to 1. That's the trig identity. So my sine square h is equal to 1 minus what? Cos square h. Now if I multiply minus 1 to both sides, minus sine square h is equal to cos square h minus 1. So we have what we have here. Please, this is equal to cos square h minus 1 all over h into what? Cos h plus 1. Please, there's a bracket here and there's a bracket here. Beautiful. So we move on. So this is equal to, fixing this there, so we have this is equal to minus sine square h all over h into cos h plus 1. This is equal to, I can split it, I can have sine h, this is sine h over h, okay, times minus sine h all over cos h plus 1. Okay, then we apply our limits. Now remember, in our limit rule, if we have the limit of the function a times b is the same thing as saying the limit of a times the limit of what? B. So we have the limit of this times the limit of this. So if we apply limit, this will be equal to the limit of this will be the limit as h approaches 0. We have sine h over h times the limit as h approaches 0. We have minus sine h over what? Cos h plus 1. Now from the first distance, we've shown that the limit of this is equal to 1. So this is 1 times, now the limit of this, apply anywhere you see h, put 0. So this becomes minus sine 0 all over cos 0 plus 1 is equal to 1 times sine 0 is 0, minus times 0 is 0, all over cos 0 is 1, 1 plus 1 is 2, so this is 1 times 0 over 2, which is what? 0 over 2 is 0, so 1 times 0 is what? 0. So we have shown that this limit is what? True. That when we find the limit of sine h over h, okay, it's as h approaches 0, it's 1, and when we find the limit as of cos h minus 1 over h as h approaches 0 is 0. Thank you very much. Please kindly subscribe and watch it again and share to your friends. Okay, spread the word of mathematics. Thank you.